Taras and I, we are working for the company who helps others to use, build products, and deploy SONiC. And as a result, we are getting all the different requests or questions that goes beyond what actually SONiC was initially designed for and where it is usually used. This time, we are not going into telco world. We are going into enterprise, campus, access networks. And here we have a little bit different context than we have in the DC. So in DC, we have enough CPU power on the switch. We have lots of memory and sufficient storage to manage several images at a time. When we go into a switch running somewhere here in the building, it's completely different story. There is small memory available. There is probably ARM or 2 ARM cores, V7 or even simpler. And storage-wise, again, we have to save on it and somehow to put several, at least 2 operating system images there. So we used to optimize SONiC to run in such a constrained environment. And this time we decided to go extreme to reduce it as much as possible and see what we can squeeze out of it. So Taras will share the details of our achievements, what we were able to get done while stripping off what we think not really necessary to run in these environments. So what I'm going to say, we have to sacrifice something in order to fit into a smaller footprint. So let's take a look at another answer to the question what SONiC is. So at high level, from our opinion, it is containerized modular architecture. We heard it from Google already. It is Debian based. One of the core components is switch abstraction interface. I think Google misses Redis DB, which is central to configuration and runtime data, communication between different components. And finally, it has to be consistent API-wise, both northbound and southbound. If we take a deeper look, there are a few more, I think, important components that make SONiC, like it's in its DNA. So we have switch state service, org agent, and multiple familiar for all the Linux community daemons like teamd, LDPD, FRR, and so on. So here we have kind of full picture, and now it is Taras' turn to make sacrifices.
Yeah, thanks. So the role of Docker in SONiC, and I believe that Docker has happened on the in the compute, in the cloud area. We know that this is the great technology, allows us to easily spawn isolated sandboxes. If I can, it's not a sandbox in a like regular environment, but sandboxed environments where you can run your applications and have them in their own world, which simplifies a lot of development, orchestration, upgrades, even isolation a bit on this, so you can have completely different applications that would typically will not run on the same server, now suddenly runs without any issues, because I don't know, libc dependencies, maybe some other inconsistent dependency. And Docker allows to transform the Linux server to the number of execution environments without almost zero performance penalty. The performance of Docker, we all know, is 98% of the regular Linux, so typically shouldn't be any issues if you are talking about performance and we are talking about the size, yes? But it's also, I believe, the cause of the problem in SONiC a bit, and I will try to convince you why. This is a quite interesting, I believe, not clear picture at all. And I've been using this picture maybe a few events ago. And each block represents the real-time snapshot of the memory usage on the SONiC device. And they're grouped based on what's happening. So on the right side of the picture, you can see we have some Linux demos like LDPD, Redis server, syncd, we have syslog, SONiC host, database weight, event-d. So as you can see, it's like only 1/3 of the whole picture. On the left side, like a big rectangles, these are the infrastructure. So these are the SONiC infrastructure, these famous Python codes and Python scripts that previous speaker was talking about, that we need to check. We need to make sure they are still running. We need to make sure they are not changed. And we also see they are quite heavy. From the memory perspective, it's like at least half of it. And why do we need those? Because we have this microservice architecture. Each service is its own world, and we need to make this world work for that specific service. It takes a lot of logic to make sure that LLDP thinks it's the one and only LLDP in the Linux system, because it was designed like that by the authors of the LLDP. So why this is matter? As Leonid was saying, SONiC was designed and works perfectly in data center. And we are going up. We are going AI networks, we are going scale up, we are going inner DC. Kamran was talking about this. SONiC there is perfectly fine. If you've seen, remember those big chips, I don't know how many zeros you need to have in a check to get those chips, but so you can get a bigger CPU and it's negligible. You can put a bit more RAM, it's also negligible, into the cost of the optics, etc., etc., etc. So we don't care if it's 1 megabyte or 10 megabytes used of the process, it works fine. Then we have much bigger issue to solve, like as Kamal was saying, latency, etc., etc. However, when we're talking about these kind of platforms, this is when we start facing some issues. Why? Because typically, when you deploy data center, and when you deploy 10,000 switches, it's a lot, but it's just 10,000 switches. So we are talking, I don't know, 100,000 ports for data center. For the building like this, we can have several thousand ports like this to power Wi-Fi access points and to connect them, to connect the VoIP phones, to connect the stations. So it's the order of magnitude more platforms like this being deployed in the world than platforms like in the data center. And by saving each and every piece of the BOM cost for this platform matters. So how we can do it? Let's run SONiC on the bare metal. What does it mean to run SONiC on the bare metal? We were saying SONiC is the Debian-based, microservice-ish architecture, because it's still questionable about microservice here. So let's think how we were running this kind of firmwares and these kind of operating systems before and how we're running them now. It's embedded Linux, purposely fit and built for that specific platform. It's native processes, which are, instead of Dockers and instead of isolation, running in the same environment. It's the minimal dependencies. There are two-sided swords, and I will talk about that, but at least we are only putting to the system exactly what we need. Instead, what we might need or we will need later on, we are optimizing each and every piece of the system to do only what we expect it to do in this specific use case, in this specific scenario, and removing everything else. We are focusing on the startup. Why I mean focusing on the startup? In the leaf spine topology, you can put the switch out for the maintenance mode. You can change your configuration to not disrupt the traffic. Yes, you might say, okay, if your Wi-Fi doesn't work for 10 minutes, it's okay. But typically, access network, there is no redundancy on the switch level. So the faster you can reboot, the faster you can reconfigure, it's better experience for the end users. And what's important, we are still keeping the same DNA. So still same database, all the same processes, all the same northbound, and the same sourcebound, same SAI, etc. So we can reuse what's been already developed and still being developed in SONiC. We can rely on the stability and the quality of SONiC itself and repackage it to fit to this more tighter environment. Next slide, please. But everything comes with the price, yes? The biggest price is the, as I was saying, isolation. So currently, I don't know how, if any of you were trying to debug SONiC, if SYNC crashes or stops working, there is a nice recovery process. SONiC will try to recover itself. And sometimes you would even not imagine that something happened unless you will check the Docker's uptime. Yeah, something was bad, but now it works again. When you don't have this isolation, when you don't have the process, the feature or the component as the separate instance in your orchestrated execution environment, now you need to check if it's there. Do you need to have some kind of either systemd or other init system checking that is happening? And the memory leak in the process affects whole system. Because in Docker, we can have the limitations, like you can put how much resources its specific execution environment can have it. You don't have it as well. You can do something with the C groups on the systemd, yes, level, but it's a bit more complex than on the Docker side, how it's, I mean, it was already done deal in Docker, you need to do it once again. It's also a bit harder to debug. Why I mean harder to debug? Again, previous presentation, you have so many Python files, you can just change your template, reload the config, and you can test something. It's bad for the hacking, but it's great for debugging. The system is open. When you optimize, you typically squeeze, squash, and even pre-compile Python code to squeeze this 10% more of execution time. So it's harder, you cannot just replace the file, you need to either rebuild the image or find a way how you can replace this binary on that. And what's also, I would say, the biggest hit is the loss of flexibility. I mean, the greatest feature of SONiC, which I believe no one talks about, but it's really, really cool, at least from my point of view, it's so-called SONiC app extension. You can formulate your Docker with the manifest file and the data inside, that on the running SONiC, you can say, I want this feature to be enabled. SONiC can download the Docker, extended CLI, extended feature config, and you now have a new functionality like SONiC Guard, for example. I believe they will do, but they will use app extensions. Or, I don't know, AI collector. This is not case here. You need to purposely define what's in your firmware and what's need to be done on that device before you start to produce it. Next slide, please. However, I believe that price is reasonable when we are talking about the results. These are the sneak peek that, to be honest with you, I was really impressed. I didn't believe, and I've asked my team to show me, like on physical hardware, to prove, because I said this is something can be done. So if you take the current latest release 24.05 of SONiC and run it on the 2 ARM cores CPU with 4 gig of RAM and 8 gig of eMMC. So typically, until you power on the device with the simplest config, like all ports in one VLAN, nothing else, it will take you at least 11 minutes until you can start pushing traffic through the ASIC. When you will try to reboot it, you will lose the connection for something about 15 minutes. When you will try to use it and to ask, show me what's current on the switch, it will take you about 13 seconds to print all the interface information on about the switch. We talk about 48, lower number of interfaces will be faster, but just to understand what foundation we were talking about. And also important part, the image that you will produce that contains the Debian, all the Docker images, the orchestration, it's compressed, but it would be about 950 megabytes. By stripping all this away and just keeping what we need, we managed to get the boot time, so the same criteria. You're powering on the device, same configuration, and how long it will take until the traffic will pass through the switch. It's about 80 seconds. If you do the reboot, you will lose the connectivity for about 2 minutes. If you try to see what is the current configuration of the ports, it will take about 1.5 seconds. But the biggest advantage, at least from my point of view, is also the installer size is 150 megabytes. So if you will install the SONiC, it will be around 2 gig on the disk. And if you will start bare metal, it will be around 450 megabytes. Next one, please. So what are the key takeaways? What are the information we can take it from? SONiC is great. We don't need to change SONiC in its core because it serves its needs. And the main use case it is targeted for is solved. And there are other which we need to extend, like Kamran was saying about inner DC, maybe even metro area, but we need to continue this. It provides you all the necessary components and all the necessary infrastructure to use it. Let's not change it. Let's reuse it to a different use case. Let's not break what's work. Let's take the parts we like and repackage it to use in another use case, which I believe would still can be named SONiC. Again, someone can disagree that you're taking the pieces and it cannot be named SONiC. But for me, if it's walk like a dog, if it's talk like a dog, it's still a dog. No matter if it's inside, it's much smaller and much lighter dog. And I believe that from the community perspective, it's a time for us to group around the use cases and purposely design the, I would say, flavors or modules or configs for SONiC for the specific use case. You cannot have exactly the same binary, which currently the case, that runs scale-up network and runs the access network. It has to be different. It can be derived from the same code base as the Linux kernel. Same code base, different config. You can produce the kernel for the supercomputer. You can produce the kernel that runs on a handheld device. So we need to work in that direction. We need to think about the option that it's no longer the case that resources are unlimited. We will face the resources when you try even on the bigger devices, but here we need to start thinking, do we really need that much Python and Jinja? Can we somehow optimize it? Something can be rewritten? Can we drop this or drop that? These decisions need to be made on the community level by keeping all benefits of the modular and microservice architecture we have now, but simplifying and maybe tighter integrating the system together, which will make life for the security much, much easier, but also the life for the slower system much easier. And it's evolution. And I believe next year we'll meet here and we'll start talking, okay, we now have the scale up, we have scale out, we have the access, we have the management. What else? What else? Let's do RAN or what? And we're done. Questions?
Well, you have presented probably the two options for using Dockers and bare metal. Have you experience about using a midterm, let's say, LXC?
If you use LXC, I mean, the whole idea of drop Docker, it's not about the Docker aspect. It's about the infra you need to make to build this isolation costs more than the isolation benefits provides. So imagine I will try to reiterate. If you will just run, like manually run, that Docker on the system and remove all the infra, you will get almost the same results as in the bare metal. So the heaviest part of it is the templating, monitoring, starting this part. So by rewriting it, I'm okay to stay with Docker. I like the technology itself. It was just much easier and faster path to get the performance by completely stripping it away.
I mean using LXC due to its lightweight than Docker in terms of the footprint that represents for the system. And let's keep, a comprise between the benefits of both worlds.
Yeah, okay, so I understand your point, but again, if you would need to switch to this and to run each project in server C, so we would need to design almost the same infra that's currently having, and even maybe more sophisticated, because Docker solves already a lot of things that we need to do manually in LSC.
Mm-hmm.
So I believe it's a good question, for the team to make some POCs, does it work or not, but I believe that by providing this facility to run it, the infrastructure to allow it will cost more than the isolation will give you benefits.
Okay, thanks.
You said at the end, we need different images for scale up and scale out. Why?
Size. It's mainly size and content.
And not only size. I think control plane is going to be content. Okay.
I will explain what I mean. I will take the extremes, yes? You still need to run STP analysis. You don't care about STP in the PC. It's just the dead code.
Right, but I don't care about the extra space to ship SDP even when I don't need it. Like there is optimizing and there's optimizing too much, and I'm really questioning if we need to remove those last few things to get the image that small. Like in most devices, the storage is not that limited.
I'm not saying remove. I want to have the option to enable or disable on the view plan. That's it.
Okay, but it's not a different image. It's still the same image, but different enabled.
No. What I mean, the result of the image that you instead ship to your customers. The lower components you have, it's easier to maintain, it's easier to update. I will explain why. For each and every component, you need to do SPDX, you need to have it in your SBOM, you need to do a vulnerability check, you need to update and keep it consistent.
But now if you have 3 images, you need to do it 3 times.
You have the common, you should do the common, and then you do other parts.
Okay.
So I understand what you're saying, but I will repeat the question in different manner. When you buy your laptop, do you like when you have the pre-installed software, or you don't, or you remove it?
I moved the SSD from my previous laptop.
Sorry. That's the answer to almost the same. I understand the restriction, and it's not just about the size of the disk, but also the operational aspect. So typically, by providing some flavoring to your deliverables, it makes your life a bit easier.
Let's agree to disagree.
Yeah,
Alex.
One question, one notice. So basically, you've been talking about some kind of embedded Linux as a base. What do you use?
Yes.
Which one?
Yocto, Buildwood,
Yocto.
whatever fits best for the community.
I believe you're talking about the YoLite SONiC or whatever you call it. So what do you use? You've been doing the measurements and something. Buildroot.
Buildroot for the baseline as the quite simple and self-contained environment.
Okay.
Which usually fits the best this.
And second is not a question, but notice I see people making photos of your presentation. Could you please upload it to this CAD? To this event, obviously you can do it.
The application will be uploaded.
We have
Because
already
I checked
shared.
now, it's not.
Really?
Okay, I didn't make any photos because I believe you will do it. Thank you.
We can share it with you.
Photos as well. I believe when I upload it, it will be much better quality.
yes.
The presentation will be shared with all participants.
Yeah, absolutely. We'll also have the recording uploaded on YouTube as well. So All right. Unfortunately, we do have to move on, but after event, feel free to connect. Great discussion and presentation as well. Thank you.
Thank you.